What they found was a really tantalizing hint of the potential that this planet might have dimethyl sulfide in its atmosphere. This will definitely need confirmation and a lot more data, but it's really exciting to see that the James Webb Space Telescope has the capability to even try such a thing. It could mean that we will find evidence for life around some other planet this decade. My name's Jason Wright. I'm a professor of astronomy and astrophysics here at Penn State. I'm a member of the Center for Exoplanets and Habitable Worlds, where we look for planets potentially like Earth orbiting other stars that could potentially have life on them and think about ways that we can show that they do or don't. I'm standing here on the rooftop of Davy Laboratory at Penn State, which hosts the Department of Astronomy and Astrophysics and the Center for Exoplanets and Habitable Worlds. And this behind me is one of the telescope domes that houses one of the telescopes that we use for outreach and occasionally for research. A team of astronomers using the James Webb Space Telescope has analyzed the constituents of the atmosphere of a planet called K2-18B, and they were looking for hints of dimethyl sulfide, this biosignature gas. This is an extremely challenging measurement to try and make. The James Webb Space Telescope was not explicitly designed to do this, and so they were really pushing the telescope to its limits. So on Earth, we have gases like oxygen and methane that are produced by life on Earth. If all life on Earth died, we would lose the oxygen and the methane in our atmosphere. So the presence of those is what we call a biosignature, a sign of biology on the planet. When we look at these other planets, we're looking for similar biosignatures, gases in the atmospheres of the planets that could indicate that they have some sort of a biosphere, they have some sort of biology going on. So we wouldn't be finding a picture that shows, forests or something like that. We're just seeing the gases in the atmosphere that says there could be life there. As someone who's been looking for planets like the Earth around other stars for his whole career, it's really exciting to be in this new era with the James Webb Space Telescope and with planned NASA missions like the Habitable World Observatory. That means that we might not just find such planets, but we could actually find what their atmospheres are like, what their surfaces are like. Do they have liquid water on their surface? Do they have oxygen in their atmospheres? And to see that it could be that within my lifetime, we will have a definitive answer that yes, there is a planet that looks a lot like Earth, and maybe even, yes, it really looks like it probably has some sort of a biosphere. It's very rewarding. And I'm really pleased that NASA and other space agencies around the world have prioritized this search because it's extremely challenging and it's going to take a huge amount of work by astronomers around the world. The heavens are just so fascinating to so much of humanity. So many people want to know what's out there, and we read science fiction and we see the movies and we imagine that it just could be filled with planets like the Earth, with alien species and forests and all sorts of stuff. It's amazing that this isn't just science fiction. We could figure this sort of thing out. It's the sort of topic that just has resonance all across America, all across the world. And so it's great that we're spending so much effort figuring out that it really can be done. For decades, NASA has been one of the crown jewels of the US government, from putting people on the moon to launching the Hubble Space Telescope, and driving us to answer this question of whether we're alone in the universe. It has great ambitions over the next few decades, if we can support those, to perhaps definitively answer this question that so many people want to know the answer to. That sits in front of this camera here that the telescope uses to find the stars we're looking for. This is the main telescope. The light goes up to the secondary and it comes down to a focus. It has in front of it this filter wheel, which lets us select certain colors of those stars out so that we can measure. This is the primary mirror of the telescope here. This is the focuser that lets us focus the camera. Here we have the filter that we use to select out just the colors, or if we like, we can make the whole image look fainter with a neutral density filter. And then there are, I guess, 40 years probably. The original telescope, we calibrate the camera, so we'll often swing the whole telescope around, stare at that